GIT 500 variables. Let's start with the question, what is a variable? Simply put, it's an image, a perception, a concept, an idea that can be measured. Anything that can be measured is a variable. You may be wondering, how do we use variables? Well, variables are used in what we call controlled experiments. A controlled experiment is a scientific test in which all conditions are kept constant, the same, except for the variable, the thing that you are testing. There are lots of ways to think about variables and to talk about variables. One of the broadest ways to think about them are the independent and dependent variables. Independent variables are the variables that you are testing, the variables that you want to introduce to a situation or a person and see if those things create change. And you can have multiple independent variables in the same study. It's also called the manipulated variable. So it doesn't get changed, but it creates changes. The dependent variable, on the other hand, this is the thing that you are measuring to see if it changed based on the independent variable that you introduced. It's also called the responding variable. This gets kind of confusing. Using this sentence structure can help you remember which is the independent and which is the dependent. So an independent variable causes a change in a dependent variable, but it is not possible that a dependent variable could cause change in an independent variable. Only the dependent variable changes when one or more independent variables are introduced. Independent and dependent variables have a causal relationship. In other words, the introduction of an independent variable brings about change to the dependent variable. It causes the outcome to change, right? Or could cause the outcomes to change. And it links the cause and effect together. The introduction of the independent variable is the cause, and the change in the dependent variable is the effect. Here's an example of the causal relationship between independent and dependent variables. Let's say we have a teenager who is trying to learn the piano and she's not doing very well. She's our dependent variable. We want to do something that might see some change in her ability to play the piano, play the keyboard. So that's our dependent variable, the thing we want to affect change on. If we get her lessons with a music teacher, that's our independent variable. That's the thing we've introduced to cause change. That will lead, possibly, to a young woman who can play the piano, the keyboard much better, and she's happier. That is, again, our dependent variable, right? So we had the dependent variable where she's unhappy and doesn't know what she's doing. The independent variable is introduced where she takes some lessons, and then the dependent variable does show change, right? So that's that cause and effect relationship. Now, sometimes introducing an independent variable to a dependent variable and there is change, sometimes that's not always a causal relationship. Sometimes other things that you may have not thought about that were introduced and you didn't count them as intervals, they may have created that change. So the way to get around that is to actually have two groups of subjects and split them into what we call experimental and control groups. In experimental and control groups, you treat the groups differently. They're both the dependent variables, but in one, the experimental, which is our top group with the young lady, that is the one where you introduce an independent variable to see if it causes change. The other one is the one we call the control group, which is the young man on the bottom, and for him, we don't introduce that independent variable. So for the young woman who is our experimental group, she gets lessons from the instructor. But for the control group, he just keeps doing what he was doing, which is practicing but not taking lessons. And then we can see from those outcomes that possibly that independent variable that we introduced with the experimental group, our top group, had a different effect than the one, the group that was the control group and didn't have that independent variable. So that's the difference between experimental and control groups, and having something to compare to see if there's actually a difference. All right, let's talk more about variable types. We talk about variables in terms of units of measurement. And then within that, we have two different ways to talk about that. We either call them continuous or categorical, or qualitative or quantitative. Continuous variables are variables that can have a whole lot of different individual values, such as age, income, weight, address, things that can just have lots of different variables because we can have people who are of age, under 1 to over 100, right? And there could be many different values within 50 people that we're getting data from, right? Same with income and weight. Categorical variables are also broken up into constant variables, dichotomous variables, and polytomous variables. Constant variables only have one value and can't be changed. Like if one of the variable is water. It's just water. Can't really change water. A tree is a tree. Taxi is a taxi. A fixed budget where there's one number. These are things that can't be changed. So these are called constant variables. So you would just introduce that one change into your experiment. Dichotomous variable means that it has two values to choose from. Yes or no, hot or cold, day or night, that kind of thing, good or bad, where there's really only two. If there are more than two, we call those polytomous variables, but they're not unlimited at that point. They're still going to have a certain set of variables that need to be chosen or applied. So like agree, neutral, disagree, red, blue, yellow, green, that kind of thing. We can also think of continuous and categorical variables as quantitative and qualitative variables. Quantitative variables are those continuous variables, while qualitative variables are those categorical variables. For example, continuous, if you ask the question about educational level, a quantitative variable, that continuous, any number could be entered in there, right? So that's the way you would ask a question if you wanted quantitative data. You would just say, how many years have you completed your education level? Qualitative, you would give those categories. And this is just an example. You could have, some high school, some college, PhD, whatever you want there. But you would be counting not the individuals like you would in continuous and quantitative data. You would be counting the categories, right? Another example is age. Same thing. Quantitative, you would be getting, however, you had 50 people, you could get, 50 different answers. Probably not, but that's a possibility. The age, again, you would have categories, and then income level, same thing. Okay? Another way to think about variables is how are they measured? And we measure them in research using measurement scales. We have the ordinal scale and the nominal scale. The ordinal scale is also called a ranking scale. It divides people, objects, responses, whatever it is you're gathering into subgroups that are ranked in a certain order. So you might ask a question about someone's education level, and the scale that is used here starts from high to low. So doctoral degrees, college graduate, some college, high school graduate. A nominal scale divides people and objects into subgroups as well, but it classifies everything. So it's the same thing as a categorical variable. So you might ask someone their profession. Are they a first responder? Are they an educator? Are they a doctor? These are very broad, in this example, classifications of profession. Quantitative designs use, as part of those nominal and ordinal scales, further delineation of interval and ratio measurement scales. So let's look at interval scales first. Again, it divides people, objects, whatever, into the subgroups. The categories are listed in ascending or descending order. They are spaced equally apart from each other. And they can start at really any value and end at any value as far as the answers available on the data question. And here is an example. When do you get up in the morning? 6 a.m., 7 a.m., 8 a.m., 9 a.m. You can see it arbitrarily started at 6. Arbitrarily, the last answer is at 9. It's up to the researcher. And you can also see that they are spaced 1 hour apart each, right? So that is an interval scale. The other quantitative design measurement scale is the ratio measurement scale. These scales, like interval scales, are like interval scales, but they always start at 0. So they don't have that arbitrary beginning time. They always have to start at 0. This is because it allows for mathematical calculations more easily. It's more easy to compare apples to apples if everything starts at 0. It's used for numerical answers, right? So height of inches, and income of dollars, age of years, and so on. And here's an example. How many children do you have? 0, 1, 2, 3, 4, 5, and so on. That last number is arbitrary, but the first one always has to be 0. A little piece of advice on writing interval questions. You need to make sure you always give every participant a possible answer to choose. For example, if you were going to ask age, you remember with interval, you don't have to start at 0. You have an arbitrary beginning and end time. But if you just say, well, I don't care about people under the age of 18, and you start with 18 to 24, and you're like, I don't care about anybody over the age of 35 or 34, and you end with 30 to 34, what about the people who are under 18 and who are over 35 or 34, 35 and over? You have to give them an option, right? It's quite possible you say, well, I don't want minors in my study. That's okay, but you have to give them an answer so you can take their data out. If you don't give a 17 and under or under 18 option, 17-year-olds are going to pick 18 to 24. They're not going to say, oh, I can't do this. And so then your data's not correct, right? And same with the high end. Make sure you give every participant a possible answer. And this is really true with the age question, but also if you're giving categories like profession, you can't possibly name every profession. So end it with an other question where they can fill it in. All right, so what we talked about today was the different types of variables, the variables used for quantitative studies versus qualitative studies, and the different measurement scales that we use.